Nitrogen hardly seems like a pollutant. After all, it makes up more than 3/4 of the air we breathe. But that's stable nitrogen. Other forms of nitrogen, like nitrates and nitrites, are causing big trouble in our drinking water. High levels of nitrate in our water can seriously affect people's health, especially infants. An estimated 9% of Wisconsin's private wells exceed safe drinking water standards of 10 parts per million. Several municipal water systems in the state also exceed this standard and require treatment. With funding from the University of Wisconsin Water Resources Institute, Bob Stelzer is helping us to better understand how streams and wetlands may help remove nitrate from the environment.
What this research is doing is looking at one aspect of the nitrogen cycle. The amount of available nitrogen on the globe has increased by about twofold over the past 100 years.
Much of this increase comes from agricultural fertilizers. To make fertilizer, nitrogen from the air is made into nitrate and other forms that plants can use. Unfortunately, much of this fertilizer washes off fields and gets into our surface and groundwater. In Wisconsin, agricultural fertilizer accounts for up to 90% of the nitrate in our drinking water. Other sources include poorly managed animal feedlots, landfills, septic systems, and runoff from lawns and gardens. All that fertilizer in our waters makes weeds grow excessively in our lakes, affecting fishing and swimming. It also contributes to the nutrients washing into the Mississippi River. The Mississippi drains 41% of the continental United States. The river dumps about 1.7 million tons of nutrients into the Gulf of Mexico each year. This ultimately causes large dead zones, hurting ecosystems and economies. Counteracting at least some of this buildup of nitrogen in the environment may be bacterial processes in streams and wetlands. Stelzer is looking at the part of the nitrogen cycle where bacteria convert nitrate back into N2, or pure nitrogen. This is called denitrification. He's helping to figure out how fast this process is operating.
Wetlands, places like rivers, places like lake sediments, wet soils are places where a lot of nitrogen can be removed or lost. And so it's very important to understand these nitrogen removal processes because they have the potential to balance at least some of the excess nitrogen that's being added to the environment every day. And so what we are really focusing on is nitrogen removal in streams, particularly in deeper stream sediments where not many scientists have looked. One of the best ones yet. Mm-hmm.
Stelzer and undergraduate student Ashley Winker are taking cores of sediments beneath 8 streams in central Wisconsin.
There we go. I can keep it straight. And push, I'll tell you when to stop.
Stelzer slices the cores into 5-centimeter sections.
Okay, go. A little more. Good. Good. See, that's really sandy there.
The hundreds of slices are taken back to the laboratory for analysis.
So I'm recording what cores we've collected and from where here.
They continue sampling at the 8 different streams.
Okay, I'm so close.
You can clearly see the sand too.
Yeah, this is beautiful. Here we are back in the lab, putting known amounts of this sediment plus groundwater into these incubation vessels, and in these vessels we'll allow the microbes to do their thing, and eventually we'll measure denitrification rate.
The microbes in the soil convert the nitrate into N2O, or nitrous oxide. Normally they would then convert that to pure nitrogen. But nitrogen is hard to measure since the air around us is full of it. So Stelzer blocks that conversion by adding acetylene. Then he can measure the buildup of nitrous oxide produced by the soil's bacteria. The result is the rate at which the bacteria get rid of the soil's nitrate. To make these measurements, Stelzer and Wilkins must replace the oxygen in the jars with helium. Getting rid of the oxygen allows the denitrifying bacteria to go to work. Stelzer's project is ongoing. Preliminary results do suggest that the bacteria in the sediments beneath the stream are removing a substantial portion of the nitrate in the sediments. This finding suggests that streams and wetlands are important places for removing nitrates from our groundwater. Nitrate pollution remains a big problem in Wisconsin, but it appears to be counteracted, at least in part, by the natural processes found in these ecosystems. This research is brought to you by the Wisconsin Water Resources Institute.